Welcome to This Explainer. Today we're unpacking a massive, truly fascinating anomaly hidden deep in the far reaches of space. It's a discovery that's literally challenging what we know about the early universe. So if you love piecing together clues to understand the cosmos, you're in the exact right place.
So what exactly is hiding in the darkest corners of the early universe? It's a question that's driven astronomers for decades. Just recently, the James Webb Space Telescope was staring deep into the cosmos, looking all the way back to the dawn of time, and it found an anomaly, a seemingly insignificant, tiny little blip on the radar that was incredibly easy to overlook. But as we're about to see, in astronomy, sometimes the very smallest anomalies hide the absolute biggest secrets.
Okay, let's dive into this with Section 1, the anomaly, a tiny discovery in deep space.
When researchers were combing through those incredible deep space images from the James Webb Space Telescope, they spotted these faint objects they affectionately started calling little red dots. Now, at first glance, these dots seemed entirely unremarkable. In a universe filled with sprawling, dazzling galaxies and massive nebulae, these faint little dots were incredibly easy to just skip right past. But researchers quickly realized these dots weren't behaving like normal galaxies at all. Something was definitely off.
Now, the first big clue was their age. Exceeding 11 to 12 billion years old, these dots existed in the universe's absolute infancy. We're literally looking back in time, seeing these objects exactly as they were shortly after the dawn of the cosmos itself. But here is where it gets really strange. Despite being so unbelievably ancient, these dots are incredibly tiny. They don't exceed a few hundred light-years in diameter. In terms of deep space, that is exceptionally small. Just for some context, our own Milky Way galaxy is about 100,000 light-years across. These little red dots are just a few hundred. It brilliantly illustrates just how unusually compact these anomalies are. You've got this massive, ancient age, but restricted to this incredibly tight, packed space. Then, astronomers looked at the temperature. That reddish color? It's a dead giveaway for low temperatures. Ranging from 1700 to 3700 degrees Celsius, this is incredibly cool compared to the scorching heat of typical stars. So we've got an ancient, incredibly tiny, and surprisingly cool object. What exactly could it be?
Which brings us to Section 2, the plot twist. Enter the Chandra X-ray Observatory. Now, what's really interesting about this is that right when scientists thought they had a handle on the Webb data, Chandra comes in and presents a massive contradiction. While JWST saw cool gas clouds, Chandra detected intense X-ray emission emerging from the exact same locations as those tiny red spots. And here's the kicker. X-ray radiation is typically formed by very intense, violent processes. The most probable source is matter being heated to millions of degrees. So one telescope sees a relatively cool 3,000 degrees, and the other sees evidence of millions of degrees.
And this right here creates a massive scientific headache. See, a dense, relatively cool cloud of gas really shouldn't be emitting visible X-rays. It should act like a heavy, lead blanket, absorbing the incoming radiation and swallowing the energy without emitting anything visible to us all the way back here on Earth. It's like trying to hide a glowing flashlight under a heavy quilt. Yet somehow, the X-rays are reaching us. How is that even possible?
So, researchers had to come up with a solution to this contradiction. And it's honestly fascinating. They suggest that the dense gas cloud isn't a solid, perfect blanket. Instead, there must be certain openings or windows within the dense gas. It's through these tiny structural gaps in the cloud's fabric that a portion of this intense millions of degrees X-ray radiation is managing to leak out and travel all the way across the universe to hit our telescopes.
And that leads us directly to Section 3, the hidden monster, an accreting black hole.
To understand what's actually hiding in the dark there, researchers proposed a four-step mechanical process. Step 1. Hidden deep within this tiny, dense gas cloud sits a supermassive black hole. Step 2. This black hole isn't just chilling there, it is actively feeding on the material of the clouds surrounding it. Step 3. As the matter falls into the black hole, the sheer friction and intense gravity heat that matter up to millions of degrees, which produces massive amounts of X-ray energy. And finally, Step 4, those X-rays find the windows in the surrounding cool gas and leak out into space for us to detect.
Now, the scientific term for this kind of monster is an accreting black hole, which basically just means a black hole that is actively feeding on the matter surrounding it. And the sheer power generated by this feeding process is staggering.
I mean, it produces so much energy that it heats the immediate environment to millions of degrees, even while the outer edges of the cloud remain cool enough to just look like a faint, unremarkable red dot to the James Webb Space Telescope. Let's move on to Section 4, the missing link, solving a cosmic evolution puzzle.
You see, scientists have long struggled to explain exactly how these supermassive black holes are actually born, and they've generally been torn between two main theories. Theory 1 suggests a gradual merging, meaning black holes slowly interact and merge with each other over vast amounts of time to become supermassive. But Theory 2 suggests a rapid collapse, where massive clouds of gas quickly collapse in on themselves, forming a giant black hole much, much faster.
So the absolutely crucial point here is this. These little red dots, they might actually be the missing puzzle piece between these ideas. They represent an intermediate state. We're essentially witnessing the very emergence of a black hole inside a dense cloud of gas, caught right in the middle of that rapid collapse process, before it ever has the chance to develop into the bright, sprawling center of a fully formed galaxy. If this interpretation holds up, these tiny, unremarkable little dots are actually the crucial evolutionary step that explains the creation of galaxies as we know them. Talk about a game changer.
Finally, we arrive at Section 5, an open case. The science continues.
Now, as insanely exciting as this hidden black hole theory is, researchers are being very cautious, and for good reason. Like any good cosmic detective story, the proof is still preliminary. Right now, only one instance of an X-ray signature has been definitively connected to one of these small red dots. Plus, there are alternative theories out there. Some experts propose that odd forms of hot dust, or maybe another unique cosmic phenomenon, might be responsible for what we're seeing. Actually, there isn't concrete evidence for the hot dust theory just yet either, but further studies are absolutely required to validate the black hole hypothesis. So, the investigation is very much ongoing.
Which leaves us with this final, thrilling question to ponder. When we look at these little red dots, are we witnessing the violent, fiery birth of supermassive black holes that will eventually shape the galaxies of our universe? Or is it really just a cosmic trick of the light caused by unusual hot dust? We are literally watching cosmic history be written, and the telescope data coming out over the next few years is going to be absolutely spectacular to watch. Thank you so much for joining me to decode this incredible cosmic mystery. Keep your eyes on the stars and stay curious.